This is lesson 1.66, subtracting proper fractions. Up at the top of your screen, you see that I have the steps to subtracting fractions, and they are almost identical to adding fractions, with the exception of step 3, subtract the numerators instead of adding the numerators. If you want to, go ahead and push pause right now and copy these steps down at the top of your page, or find a margin, or maybe on a separate sheet that you can attach, or even a post-it note. Push play when you're ready to begin to see some examples. Okay, I'm going to do a few examples with you. I'll do 3 of them with you, and then you can do the rest for your own practice. Because of the limited space, I highly recommend that you do these on a separate sheet of paper, because there's really not enough room on this page to do all the steps at once. Alright, the first step is you need to convert any mixed numbers into improper fractions. All of these problems here are all going to be proper fractions, so we get to skip step 1 on all of these problems today. On your next lesson, you will have mixed numbers that you'll have to convert. So the next step is, if there's no common denominators, then you'll need to crisscross. So look at problem number 1. Do we have common denominators? No. So we need to crisscross. Cross multiply 10 times 2 equals, and I'm just going to go ahead and kind of set this up for a second. 10 times 2 is 20, and then 5 times 8 is 40, and then applesauce. We multiply our two denominators together. 10 times 5 is 50, and that becomes the denominator of both fractions. Now that we have two fractions with common denominators, our next step is to subtract their numerators. The numerators, if you recall, are the top numbers. So 40 minus 20 is 20, but your denominator stays the same. It's 50. Convert improper fractions to mixed numbers. We have 20 over 50. Is that improper? No, it's not top-heavy, so we don't need to do that step with this problem. And finally, reduce. You have 20 over 50, and I'll show you a quick trick with numbers that end in 0. Normally we would find the greatest common factor, but if both numbers end in 0, then you can cross off the zeros because both of them can be divisible by 10. So your final answer is 2 over 5. Pretty quick trick, isn't it? Saves you time to know some of those other special rules. Look at problem number 2. I'll use a different color because I don't want to overlap here. I'll go back to my steps here. First step, convert mixed numbers to improper. We don't have to do that with this problem. Do we have common denominators? No, we don't, so we need a crisscross. I'm going to go ahead and set up my problem here. 2 times 1 is 2. 4 times 1 is 4. And then applesauce, you multiply the two denominators. 2 times 4 is 8. And that becomes the denominator of both fractions. So now we're ready for step 3. Subtract the numerators. 4 minus 2 is 2. Your denominator stays the same. Convert improper fractions to mixed numbers. 2 over 8, is that improper? No, it's not top-heavy. So we don't need to do that step. And finally, reduce. 2 over 8. So I'm going to find the greatest common factor of 2 is just 1 and 2 are the only factors of 2, so that should be pretty easy. The factors of 8 are 1 and 8, 2 and 4, and that's it. So the greatest common factor is 2, therefore 2 over 8 reduces to 1/4. And that's your final answer. So as you can see, all of these problems are almost identical to the same steps you have for addition. Let's do one more. Go back to my steps here so I can see them. Convert mixed numbers to improper. I don't need to do that with this one. Do they have common denominators? No, they do not, so I need to crisscross. I'm going to go ahead and set up my problem here. Oops, now equals minus this. What is it? 4 times 1 is 4. 2 times 3 is 6. And then you multiply your two denominators. 4 times 2 is 8, and that becomes the denominator of both fractions. Now you're ready to subtract your numerators. 6 take away 4 is 2, and the denominator stays the same. I want to make sure we had, this looks like identical to what we had before. Just making sure, yep. And we already did in the previous problem, we found out that 2 over 8 equals 1/4. We shouldn't have to do it again. Okay, do you see the steps? You know what to do? Go ahead and try the rest for practice, and then check your work. Ask your instructor if you need more help or need more practice problems.